This is bullshit. Today I want to talk about the second question of homework 5. So for the second question, there is 4 parts. Let's do it one by one. For the first one, they want us to draw the non-zero definition region of fxy. So I want to read the key information for the draw first, which is y bigger than 1. And x is from 1 divided by y to y. So from these two information, we can know there is two key parts, which is there is two lines, which is x equal y and x equal 1 divided by y. 1 divided by y, x equal. So we can draw these two lines, and because y is bigger than 1, so we need to draw this part which is 1. So y is bigger than 1 is above part, and from 1 divided by y to y is middle part of this one. So this is a graph. After that, the second part, they want us to find a so that fx is valid joint density function. As we know, there is formula from class which is fxy equal x to negative infinity y to negative infinity f theta beta times d theta times d beta. In this part, we need to use this formula, because when we put all the equation into this part and then take two derivative after that, which is equal to 1. And then we can get a when we take all the derivative. So let's do it. First, we need to write out the y part, because it's from infinity to 1. They already gave us before. And x part, which is y to the 1 minus y. And the equation they give us is a 1 over a times y squared times x, and times dx, this part in inner, and the outer part is this part. After that, we take derivative dx first. As we know, we take derivative x first, so we don't care a and y squared, so we can directly move it out, which is this 1 over a y squared y divided 1 over x times dx times dy. So take derivative in here, and we get 1 over x, take derivative which is line, so which is equal line x from y to 1 minus y times dy. After that, put y into there, we can get theta infinity to 1 over y squared, which is equal to line y minus line 1 over y times dy. In here, I want to talk about one formula which is easier for us to calculate this part. So which is line x over y equal line x minus line y. So we can use this formula in here to make it more simple, which is from infinity to 1, this is infinity, a y squared, which is line y divided by 1 divided by y times dy. So we calculate this part, which is equal to line y squared. So line y squared times dy. After that, I want to talk about another equation for line, which is line x to y equal y times line x. So we can use this equation in here too. We can make 2 out, which is 2 over ay squared line y times dy. So in this part, it is more us to calculate in the future, which is we can put the other part which is not used for us, which is 2 over a out, because we already finished x part. We need to calculate y part first. Line y divided by y square times dy. So I want to make us easy to calculate, so I make w equal line y, so we can get y equal e to w. After that, we can calculate 2 over a from theta to 0. To this part is 0 because we change the line y to w, so which is w to e to the 2w times d, because we change y, so every part of y is to e to the w, and which is we can make this out, which is 2 over a infinity to 0 w e to 2w times ew, so this part can cancel, times ew, and this equals theta 0 w times e to negative w, which is equal dw, and then we put this part in here. After that, take derivative, which is equal to negative 2 over a w e to negative w infinity to 0 times e to negative w to take derivative. After that, we can calculate negative 2 over a, because this part is just 1, just negative 1, sorry, so just negative 1, so we can calculate out, which is negative e to ew infinity to 0 equal 1. So because this part is a negative 1 also, which is 2 over a equal 1, a equal 2, so we calculate out 2. For the third part, they need us find and draw the merge and density function of x and fy. So as we know, merge and density function we already learned from the lecture, which means fx we just need to take care of x part. For fy we just need to take care of y part. We don't need to take both like the before. So let's calculate fx first. Fx equal infinity to infinity fxy xy, just take derivative of dy times dy. So there is two situation for x part, which is from 0 to x to 1. So fx equal infinity to 1 over x, 2y square x, or 1 over 2y square x times dy. So take derivative of y. We don't need to take care of x part, because in this part we just need to get the density merge and density function of fx. So just take derivative of y part, which is equal to 1 over negative 2 times y times x, from infinity to 1 over x, and then calculate this part. Negative, because infinity is just 0, and minus this part, which is minus 1 divided by negative 2 times 1 over x times x, which is equal to 1 over 2. So this is the first part of fx. And also there is a second part of fx, which is 1 to the x to the infinity, which is fx theta infinity to x to square x times dy. So seeing derivative like before, we can get 1 over 2x squared. So from our above, we already calculate, we can draw a graph there is separate part. First from 0 to 1, 0 to 1, which is 1 divided by 2. We already calculate that, which is a strict line to the 1, and the other part which is 1 over 2x squared, so it's like this, x fx. So this is the first part. For the second part, we need to calculate the fy. So when when y from 1 to infinity, we can calculate it infinity to negative infinity. I want to write out the function formula first. So this is formula for calculate margin density function of fy. So which is equal to y to 1 minus y squared x times dx. This value already gave us from the question. And take derivative is equal to this part. This is 1 to infinity. And for the other part, otherwise, which is just 0, so we can draw graph. As we know, this part graph from 1 to infinity, so the graph of it is like this. So this is the graph for fy. So this is for the third part. Found the density function and draw the density function and draw. So last part, verify fx and fy are valued density function. So how to verify it is just take derivative of fx and fy separately. If the answer is equal to 1, which is which can verify fx, fy are valid density functions. So let's us to calculate infinity to negative infinity fx times dx. There is two parts, 1 over 2 already calculated from third part, plus because there is two parts, we need to write two parts, 1 over 2x squared times dx. Take derivative of this part, which is x over 2 from 1 to 0 plus negative 2x, 1 over 2x, negative 1 over 2x from infinity to 1. We can calculate out 1 over 2 plus 1 over 2, which is 1. So verified. For other part, infinity to negative infinity, fy times dy. Put the value we get above, line y to the y squared times dy. Use same idea as we use from the second part. Let y equal e to w, and this part is equal to take derivative, and which is equal to e and minus w e to the negative w, which is from infinity to 0, plus derivative infinity to 0 e to the negative w times dw. This is use the formula of integral. So after that, calculate it out, which is equal 1 also. So verified. So that's all for the second question.